All right, good morning, everyone. Good morning, everyone. Let's kind of talk today about what we're going to be working on. I did want to switch up our activities just a little bit today, just because felt like there was, I don't know, this unit, I feel like it's just been kind of clumped up a little bit weird. Sorry, hold on. Alexa, turn off. The unit has been set up just a little bit where I feel like with us going from being in the classroom to now being online, I feel like there's a little bit of jumble. So we are going to review today. I'm going to pull up the study guide and go over some of the questions just to make sure that you feel really comfortable with it. And then I'm going to open up the tests for you to take twice, so 2 attempts, which is normally not what we do, but since the circumstances are what they are, I kind of felt like that was something that might be beneficial to all of us. So as we move through today, I want to go over the study guide and ask as many questions as you have. And then the test is open for you to take. So I want you to be able to have all of the notes available, the study guide available. As you can see, I have the picture that I shared with you guys yesterday. That is really important. So just kind of use this as well. So as we move through today, we're going to talk about that, and then you can log on and take the test today. And if you don't feel like you've done very well, take a break. Take it again tomorrow. We'll come back on tomorrow and review a little bit more, field any questions that maybe you've had over the study guide, and then kind of move from there to into space on Monday. So that's kind of my idea there. So let's just kind of look at this in general. Let me, darn it, I knew I did that wrong. Hold on, I'm sorry, I clicked it wrong. Sharing again, there you go. Let's just look at this picture, if it pulls back up for me. There we go. Make it full screen. There we go. So a couple of different things is this picture is going to be super helpful for your test taking, because there's several questions that are going to talk about wavelength. It's going to talk about frequencies, as well as it's going to talk about radio, microwave, infrared, gamma, UV, X-ray, infrared, visible, UV, X-ray, gamma. Went the wrong way there. So these are all really, really, really important to kind of have stuck in your head. So just a couple of like grasping moments before you move on is that when you are looking at the spectrum, I want you to start thinking, oh, if I'm looking at something that is in the red, orange, or yellow, I really want your brain to start going to, well, that means that it has a long wavelength, and therefore it has a low frequency. And if you think about the Doppler effect, if we're thinking about sound, if the object has passed by you already, you're going to receive that low frequency, low energy, low pitch type of movement. Whereas if we're talking about something that has a very short wavelength, we are discussing something that has a very high frequency and high energy. So something more damaging. So if you think about your project that you did, some of you kind of picked here in the microwave and some of you picked more here in the gamma. So it kind of just varies just a little bit. So keep that in mind. And then as objects move with the Doppler, it's going to depend on where you are. So if you are in front of the object that's moving, you're getting that high frequency, and if you are behind it, you're getting the low frequency. So tonight I think it's supposed to storm, or tomorrow. So meteorologists right now are trying to figure out how fast the object is moving by looking at its frequency as the storm is coming towards the greater Cincinnati area. They're not so worried about once it passes. They're mostly worried about when it's coming towards us. Let me pull up now. Give me 1 second, and I'm going to pull up the study guide. So you might want to get out a sheet of paper to kind of help you with that. Give me just 1 second. Let me pull it up for everyone.
Got it. I got it. I was thinking about it.
All right, perfect. So let's if you don't have the study guide printed, that's okay. It is due. It was due last night at 11:59, and one of the reasons that I'm going back over this is that Ms. Wall and I kind of felt that there was a lack of submitting the study guide. So if you haven't done that, please do it today. If you even just want to take notes from what we are talking about today and take a picture of it and upload it on Canvas, that is fine by me. Or if you want to open it up as a Google document and then talk about it and answer your questions that way and submit it, that's fine. Do make sure you do that though. That is a participation grade for you. So that is something that I need for you to do. So if you haven't done it already, just go back and do it. I can even change the date so that it won't be counted as late. I'm okay with doing that since we're kind of refixing and reworking today and tomorrow. So once again, study guides due this evening. Make sure you take the test sometime between today and tomorrow. Have all your materials available. We will have you take 2 attempts. So take one today. If you don't feel like you've done well, log in tomorrow. Let's conference a little bit about some of the stuff, and then you can take it again tomorrow. But let me go ahead and go over the study guide with you here. So, yeah, Cameron. Okay, that's all right, Cameron. That's not a big deal at all. When we get to those questions, which 2 are they? Let's start there. Which ones were you struggling with? Because if you're struggling with them, more than likely someone else is struggling with them too. Oh, okay, good one. So let me see if I can find that down here. Let's see here. Sure. And it's probably just because, once again, we've kind of been scattered just a little bit. So hopefully you can see that on the screen up here. So is light a mechanical wave? So think mechanical means that it can travel through it needs a medium to travel through. So a solid, liquid, gas. So it can be a mechanical wave, but it doesn't, so more above, it doesn't need to be. So think about stars. They travel millions and millions of miles that light does to reach the earth. And so it travels through space, and space is a vacuum. It doesn't have a medium in it. So technically light does not need a medium. So it is not a mechanical wave. It's much more of an electromagnetic wave. So think about like in the spectrum, that visible light section, that's where this is kind of trailing with, is that it's that visible light that breaks down then again into our Roy G. Biv, but that is that section where it does not technically need a medium. So even sunlight from the sun. So the sun is, if we think about it, yeah. Well, it's emitting all different types of radiations. It's got radio, it's got UV, it's got microwave, but clearly it does also have UV radiation too. And that travels from the surface of the sun to Earth, and there's no medium in between that. So therefore it can be a electromagnetic wave because it does not need a solid, liquid, gas to travel through. Does that help? Okay, good. So I'm sure there was others that with that question too. And light, we probably didn't talk about as much. It's just kind of lumped into the spectrum. Just understand that so if we think about the intensity, there's a question on the test that will talk about like brightness. So, and just think about it. If an object is closer to you, that light is going to be more intense, more bright, an object that wouldn't be. So I'm going to use space again as an example. The closest star to us is the sun, and it's really bright. It's made Earth what it is, which is really important. But if we think about the next closest star to us, which I believe, and I'm probably going to get this wrong, I think it's Betelgeuse, or it's one of them. It's clearly not as bright as the sun would be. So the intensity changes because the distance changes, but it can all travel through space with no medium. So, and if you think about it, when we look at stars at night, they twinkle, and they do that because that light is now traveling through a medium to get to your eye. It's traveling through our atmosphere. So, well, yeah, so while the star is producing the energy, and then that beam of light is coming towards us at a certain speed, and then when it hits our atmosphere, it kind of shatters a little bit. Kind of think of like a rainbow would, and that's why we get that twinkling effect. If we were to look at stars via the moon doesn't have an atmosphere, so they wouldn't twinkle. Does that make sense? So they shimmer or twinkle because they are now moving through a medium to reach you here on Earth, and it's traveling through the Earth's atmosphere, which is a medium. But they do not need a medium. Yes, in that visible light section. So let me pull back up. Let's see here. I've got a lot of things going on up the top of my screen. Let me pull up. Actually, let me do this. I can't keep track of all my tabs today. There we go. So I'm going to go down. Go up. So this section right here in our spectrum, the G, once again, it breaks into all of those different colors so that we can see it. So light is the presence of every color: red, orange, yellow, green, blue, indigo, and violet. Does that help? Okay. Oh, that's okay. Well, good. I'm glad that I helped you with that. Yeah. So think about, like, and I kind of made this scenario with my last class. Think about if Ray-Ban, the sunglass makers, came out with sunglasses that you could see all of the spectrum. So right now we only really see this part of the spectrum. I can't go outside and be like, wow, look at all the radio waves circling around me, or wow, look at all the UV rays circling around me. We know they're there, but we can't see them because our eyes are only made to see this part of the spectrum. So if that company were to make those sunglasses and then you put them on and go outside, you would see all of this. It would be probably overwhelming. So much energy coming through a system, like through to your eyes. It would probably make you sick. Yeah, well, they don't exist. You make them though, Cameron, then you can charge whatever you want on them, okay? But so I know I keep alluding to space, but satellites do this. So you might have heard of the satellite, and I totally just went blank on its name. Oh my gosh. What is the name of it? I'm sorry, I totally went blank on the name of it. There's a satellite that will take pictures of these different, so it has a shutter that will get rid of the visible light and then just take pictures of the light or the energy coming as a radio wave, or